Hi everyone, we are Viet An, Kinh Yuzhong, and Carthigram, and today we will present you the project Synergy, which is our simulation model. Our project focuses on two problem spaces. There is currently too much waste, and everyone is looking for renewable energy. Plastic waste has high energy value, as high as natural gas and a lot higher than coal. It is a clean and renewable source of energy, and reliable technology has been developed for 10-15 years at least, but it is not a large business in the United States yet. Why not? Because of high capital costs that incurs of implementing a waste-to-energy facility. Because of uncertainty and variability that comes along with the feedstock, there is variability in amount and frequency of waste we collect from the curbside, and there is also variability in the composition of the waste we can collect. There are also multiple factors to take into account, from transfer station to a plant. There are logistic costs, operational costs, tipping fees. So there is not enough insights for companies now to take a lead. Our solution is to build a simulation model that could analyze different scenarios and inputs, such as different locations and different technologies, determine if the business is profitable, and then optimize scheduling, logistics, and plant design. So this is a simplified model. You can see that wastes are starting from transfer station. They are being transported via trucks to a storage area in a plant, and then a forklift will pick them and bring them to a conversion process chamber, where there will be two outputs, syngas and ash. Syngas will be processed in the gas turbine to produce energy that will be sold to the grid, and ash will be landfilled. We can use as inputs waste arrival rate, plant capacity, different technologies that differ in cycle time and efficiency, different operational costs in different locations. As outputs, we will get total costs and total revenues, which are our main concerns, and other outputs such as time in storage and process utilization, which will help us optimize plant design and scheduling. So we'll show you now how our process is working. So this is our simulation model. We will run it by using the run button. As you can see, the time is moving on right now, and trucks are scheduled to pick up the waste at 8 and bring it to a storage area. After that, they will be brought by the forklift to a process chamber where they will be processed and transformed into energy and getting out in energy output. So this is a model dependent on time. And now we'll show you how to use this model. We go into the scenarios folder here and go into the design. So here, as you can see, we have different scenarios. For example, gasification in Hawaii, gasification in Mexico. You can build your own scenarios. These scenarios will be run a certain number of time, which corresponds to replications. The more you run them, the more you have a precise average. After, you can input different controls such as waste load, tipping fees, how much you get from selling energy to the grid, how much time is the process, how much ratio, different costs, which correspond to different data that we would get. So we will run it by using the run button. As you can see now, the replications are running. And after a while, we will get the results. So here we can see the results in the response, and we can see different total profit, for example. So now we can have more detailed data by going in the response result. Here you can see different things. You can see the mean and the mean answers. You can see different percentile, upper and lower percentile, different confidence intervals, and the total range of all observations. You can see also different histograms from the simulation we've got. So this will give us much insights into how a company would be profitable by using weather scenario, and so different locations and different technology, and how much it expects to earn in total profit. So this ends our demonstration. Thank you for your time. You can contact us at our contact here if you have any questions.